Okay, let's dive right into this explainer. We're going to explore the fascinating journey from those frustrating AI hallucinations all the way to highly reliable enterprise-grade reasoning engines. Look, if you've been working with generative AI lately, you already know how incredibly capable the baseline models have become. But you also know that in a real-world production environment, raw capability just isn't enough. So today, we're going to unpack exactly how we bridge that gap.
Now, this number might shock you, but industry data suggests that over 40% of AI project failures actually stem from poor context, not bad models. Just think about that for a second. It's kind of like having an incredibly smart, highly capable employee, but trapping them in a windowless room, right? No internet access, no company files, zero connection to the outside world. No matter how smart they are, they're going to have to start guessing. And in AI terms, well, that guessing is exactly what we call a hallucination.
Andrew Karpathy, definitely one of the leading minds in AI right now, actually sums up our focus perfectly here. He says, context engineering is the delicate art and science of filling the context window with just the right information for the next step. We absolutely need to master this art of getting the right info to that smart employee at exactly the right time. It's no longer just about dumping a bunch of data into a prompt. It's a true, rigorous engineering discipline. Here's our roadmap for today's explainer. First, we'll hit the AI hallucination problem. Then, RAG, or the open book exam. Third, GraphRAG and connecting the dots. Fourth, the major shift toward context engineering. And finally, building reliable AI agents. All right, section 1, the AI hallucination problem, or really, why smart models fail. So, you might be thinking, well, models today have massive context windows. They can process hundreds of thousands of tokens, which are essentially just chunks of words all at once. Let's just give them everything. But actually, simply flooding an AI with data causes what researchers are calling context rot. Even before hitting the hard token limit, the model's ability to recall specific facts starts to seriously degrade. It just gets completely overwhelmed by the noise, which leads to ignored instructions and, yep, you guessed it, a lot more hallucinations. Moving on to Section 2. RAG, also known as the open book exam, and how we ground AI in actual facts. Our first major solution to this problem is RAG, which stands for Retrieval-Augmented Generation. Basically, instead of relying purely on the static weights the model was originally trained on, RAG acts as a highly dynamic search engine. What's brilliant here is that it decouples your knowledge updates from those super expensive model updates. So you don't need to retrain a massive model from scratch every single time a company policy changes. You just update your external database, and RAG retrieves that fresh information on the fly. To put that into perspective, RAG essentially transforms the AI from a student who's blindly guessing from memory into a student taking an open book exam. By grounding the generation process in actual retrieved documents, organizations are reporting a massive 70 to 80% reduction in hallucinations. That's a game changer. It forces the LLM to become a reasoning engine over verified sources, rather than just a free-form text generator making things up. And this framework is evolving incredibly fast. We didn't just stop at naive RAG, which is basically just chunking text and doing basic semantic searches, meaning it searches by the underlying meaning rather than just exact keyword matches. We've moved through advanced RAG, which mixes in keyword searches and re-ranking, and now we are fully in the era of agentic RAG. This is where the AI agent makes a first pass, looks at the data, realizes it might not actually have enough info to answer the question, and independently goes right back to search for more. It's iterative and it's absolutely powerful. Which brings us to Section 3, GraphRAG, connecting the dots, and moving from mere similarity to actual relationships. Enter GraphRAG. Standard vector search is great, but it really just looks for chunks of text that are mathematically similar to your query. GraphRAG, on the other hand, extracts specific entities. We're talking people, companies, products, things like that, and maps out exactly how they connect to one another. It builds a literal interconnected web of your data. So, here's the absolute critical difference between the two. Vector RAG finds content about the same topic, but if you ask a complex, multi-hop question like, hey, which suppliers are connected to the delayed products mentioned in recent customer complaints, standard vector RAG usually just fails. And that's because the answer spans multiple, totally disconnected documents. GraphRAG, though, it physically traverses those established connections in the graph to assemble a precise relationship-aware context. And the ROI on this is staggering. Seriously, on highly complex schema-bound business queries involving structured data, optimized GraphRAG can jump from a literal 0% accuracy rate, meaning a complete failure by vector RAG, to over 90% accuracy. We're talking about a 3.4 times overall improvement on enterprise benchmarks. It literally turns your AI from a creative little assistant into a trusted, hardcore data analyst. All right, section 4, the context engineering shift and how we are moving way beyond just prompting. This is the big shift we've been building towards today. Context engineering treats the AI's input as a dynamic, programmable interface, rather than just a static text box where you type a clever prompt and hope for the best. It's all about programmatically managing the conversation history, the external documents, user profiles, and even real-time APIs. Also, the model always has exactly what it needs, right when it needs it. Think of it like this. If prompt engineering is just writing a really good, highly persuasive letter to the AI, context engineering is constructing the entire postal system. You aren't just writing the letter. You're designing the office the AI works in. You're building the filing cabinets it searches through, the phone it uses to call APIs, and the memory of all its past conversations. You are designing the entire environment, not just the instruction. And to prevent that nasty context rot we talked about earlier, context engineers rely on a symphony of 4 main operations. They offload static data to external databases. They actively reduce or summarize old information to save precious token space. They retrieve specific facts right when they're needed. And finally, they isolate context, which ensures that different subtasks or agents only ever see the information strictly relevant to their specific job. This is absolutely crucial for keeping the signal-to-noise ratio incredibly high. Let's bring it all together in Section 5, Building Reliable AI Agents and the Power of the Agent Loop. The agent loop is basically the fundamental architecture that transforms static, one-shot AI tools into truly dynamic systems capable of complex, multi-step problem solving. This is the exact point where the AI stops just answering your questions and actually starts doing the work for you, operating over hours or even days. It really all comes down to this continuous, iterative cycle. First, the agent perceives its environment by gathering context. Next, it reasons over that data to decide on the best strategy. Then, it acts, maybe by executing a tool like running a SQL query or making a GraphRAG search. And then, and this is the crucial part, it learns. It looks at the result of that action and integrates it right back into its memory as fresh context to inform the very next loop. Now, this loop doesn't just happen by magic, right? It snaps together through a really robust architecture. You've got an orchestrator managing the entire flow. You have a context engine acting as the brain's filter so only highly relevant data gets through. You've got persistent memory systems so the agent actually remembers what it did 5 loops ago. And of course, seamlessly integrated tools. This structure is exactly what ensures your agent doesn't just get stuck in infinite loops or suffer from context drift where it totally forgets its original goal. So when we look at the state of enterprise AI right now, a profound shift has occurred. A model's intelligence is now much less constrained by the model itself. I mean, the frontier models today are all incredibly smart. But today, real-world performance is determined almost entirely by the quality, the structure, and the relevance of the context that we provide it. Context literally sets the upper bound of your AI's intelligence. I'm going to leave you with this provocative thought to ponder for your own enterprise AI deployments. If you're out there struggling with accuracy, hallucinations, or getting the AI to do complex reasoning, you might need to stop blaming the model and start looking closely at your data environment. Your model is smart enough, for sure, but is your context? Thanks for joining me on this explainer, and I will see you in the next one.